Good morning, my dear students. I hope all are safe. Okay, today's topic is characteristics of p block elements. We know that the periodic table is divided into different blocks: S block, P block, D block, and F block. We already studied about S block elements. Today we will discuss about P block elements. The elements belonging to the group number 13 to 18 are known as p block elements, and they are known as p block elements because their last electron goes to p orbital. So their electronic configuration will be ns2 np1 to 6. When considering group number 30, the elements will be boron, aluminium, gallium, indium, and thallium, in which the boron is a non-metal and others are metals. That is, aluminium, gallium, indium, and thallium are metals. And coming to their general characteristics, the first one will be atomic and ionic radii. We know that on moving down the group, the atomic and ionic radii increases because when the number of shells increases, the atomic number increases, the number of shells increases. So the atomic size also increases. So moving down the group, the ionic and atomic size increases. And the second property is melting and boiling point. The melting and boiling point decreases on moving down the group. Next one is ionization energy. Then what is ionization energy? Ionization energy is the energy used for removing the outermost electron from any element. On moving down the group, ionization energy decreases. Why this decreases? On moving down the group, we know that the size increases. When the size increases, the distance from the nucleus to the outermost electron decreases. So the nuclear charge felt by the electron will be decreases. So it is very easy to remove the outermost electron. So the ionization energy, that is the energy needed to remove the last electron, will be decreases. So the down the group, the size increases and the ionization energy will be decreases. Next will be electropositive character. What do you mean by electropositive character? Electropositivity is the ability of an element to remove its last electron. That is, when the element is electropositive, it is easy to remove the electron present in the last orbit. So when moving down the group, the elements have less electropositive character. That is, the elements of group 13 will be less electropositive. That is, they do not wish to remove their last electron, though they will be electronegative in character. Next property is tendency to form covalent compounds. Covalent compounds, you know that they are formed by the mutual sharing of electrons. So in the group number 30, boron shows covalent character and the other element shows ionic character. What do you mean by ionic character? Ionic character is when an ionic compound is formed between two elements. One will be electropositive and another will be electronegative. That means one will donate its one electron, other will accept its electron. So in the case of boron, it shows covalent character. That means it can share its electron to another element and form a covalent bond and form a covalent compound. And other elements will show ionic character. That is, they will form ionic compounds. Next will be the comparative study of the compounds of group 13 elements. That is, their hydrides, oxides, hydroxides, etc. That is their hydrides. We know that hydrides mean when boron reacting with hydrogen, it forms hydrides. And other one, that is aluminium, indium, thallium, etc. They also form hydrides. So boron forms a number of hydrides having the general formula BnHn plus 4 and BnHn plus 6. That are the general formula of hydrides of boron atom. And the compounds of boron and hydrogen are called boranes. That is, the hydrides of boron are known as boranes. There are lots of boranes present in this world. And these contain special types of bonds known as multi-center bonds. An example is when sodium borohydride is reacting with aluminium chloride, it will form aluminium borohydrides. Next one is oxides and hydroxides. All the elements of group 30 form oxides having a general formula M2O3. For example, B2O3, Al2O3, etc. And the oxides of boron, that is B2O3, is known as boric oxide and is formed by the reaction of H3BO3. H3BO3 is boric acid. From that we get B2O3. The oxides and hydroxides of boron are weakly acidic and therefore react with alkalis. Example is when B2O3 is reacting with sodium hydroxide, we can form sodium metaborates. So today's topic is over. I think it is clear for all. If you have any doubts, feel free to interact. Thank you. Bye.